Hello and welcome to this video for the 2021 Level 2 Calculus paper. So for this paper, I actually, like my previous papers, I don't have the marking schedule as of right now. So I cannot be sure what is the actual grading for each question. However, I will give my best to give an educated guess on each of the grades for the questions. And also as a disclaimer, there is possibility that I do make a mistake during this walkthrough. And if there are some mistakes, I would appreciate if you can point it out in the comment section below. So question number 1, a function f is given by f of x equals to 4x cubed minus 2x squared minus 7x plus 4. And then use calculus to find the gradient of the graph at the function with point of x equals to 3. So this is a question A, this is a question they give, every year it's the same question, they'll give us A. So basically what we need to do is we need to differentiate to find the gradient function, and then plug in x equals to 3 to find the gradient at this point. So by using the power rule, we know that f dash of x. So in this case, we're going to multiply the coefficient by the power and then take the power down by 1. So 4 times 3 is 12, and 3 minus 1 is 2. So then we're just going to repeat this for all of the terms in the function. So negative 2x squared becomes negative 4x, negative 7x becomes negative 7, and plus 4 just differentiates to 0. Now we just need to plug in the point of x equals to 3. So f dash 3 is equal to 12 times of 3 squared minus 4 times of 3 minus 7. And if we just use our calculators, we have 12 times 9 minus 12 minus 7. So we have 89. So we should have 89 as our final answer for this question, which is the gradient at the point of x equals to 3. And this should just be a standard achieve level question. For the cubic function f of x equals to half of x to the power 3 plus half of x, find the equation of the tangent when x equals to 2. So it's a very similar approach to question number 1. We know that the tangent of a curve has the same gradient as the curve at x equals to 2. And then all we need to do is substitute a point on the curve, which is in this case will be xy. So we substitute x equals to 2 into the function to find f of 2. And we're going to use this initial condition to find the straight line in the format of y equals to mx plus c. So for these questions, we should normally just follow through on the first step. So we differentiate our function. That's going to give us 3 over 2 x squared plus 1 half. Now we need to find the gradient at the point x equals to 2. So f dash of 2 is equal to 3 over 2 times 2 squared plus 1 over 2. This is 3 over 2 times of 4 plus 1 half. And that should give us an answer of just 6.5. So now we know the gradient of this, gradient at the point of x equals to 2 is 6.5. So therefore the gradient of the tangent is also 6.5. So y equals to 6.5x plus c. And we need to find one point on the line to find the equation of the line. So therefore we can say it touches the curve at x equals to 2. So f of 2 is equal to 1 half of 2 to the power 3 plus 1 half times of 2. So in this case, we're going to get 2 cubed is 8. So 8 over 2 plus 1 half times of 2 is just 1. So this will give us 4 plus 1, which is 5. So therefore, we know that the line passes through the point 2, 2,5. So therefore, we're going to substitute this point into this equation to find the tangent. So 5 equals to 6.5 times 2 plus c. And therefore, 5 equals to 13 plus c, and thereby c equals to negative 8. So the equation of the tangent is y equals to 6.5x minus 8. And this should be a very common merit level question, with an achieve question being able to find the gradient at x equals to 2. So the number of daily viewers for a new presenter on a video game streaming service can be modeled by the following equation. So we have this equation here. And v represents the number of daily viewers and t represents the time in months. Find the rates of change of the daily viewers with respect to t when the number of daily viewers is 3,520. So this question might seem very, very different to question A here, but in reality it's asking the exact same thing. It's just asking us to differentiate the function and then trying to find the rate of change, which you can view it as the gradient when the number of daily viewers, or in this case, is 3,520. So it's a very, very similar question to question A. So in this case, we will differentiate our functions. We have v equals to negative 11t squared plus 528t. So therefore, dv over dt is equal to negative 22t plus 528. And we want to find the rates of change when the daily number of viewers is 3,520. So we want to find the times where, sorry, I'm stuttering a little bit, sorry. We want to find the times in months when the daily viewers is 3,520, and then we're going to substitute those time values into the dv over dt to find two possible rates of change for the daily viewers when it is 3,520. So 3,520 is equal to negative 11t squared plus 528t. So therefore, negative 11t squared plus 528t minus 3,520 is 0. So for this one, you can just use a calculator. Okay, so just go to the equations and then solve the quadratic. And we should... Oh, sorry. Alright, so solving this equation, we should get an answer of x equals to... sorry, not x in this case, would be t equals to 8 and t equals to 40. And we're going to check if these t bounds are in the range of t is less than or equal to, sorry, if t is between 0 and 40. And yes, indeed, both t values are between 0 and 48. So this both are fine. So now we're going to substitute these t values back into our equation for the rate of change. So dv over dt is equal to, so substitute t equals to 8 first. We have negative 22 times 8 plus 528. So, which is equal to 352 views per month. And now we're going to substitute t equals to 40. So dv over dt is equal to negative 22 times of 40 plus 528. And that gives us negative 352 viewers per month. Alright, so that's it for this question. So we found the rate of change of viewers per month for both of those t values, and that should give us a merit grade. And in terms of an achieved, I would say if you can get up to finding the derivative and also finding t equals to 8 and t equals to 40, that should be enough for an achieved. What is the maximum number of daily viewers that this new presenter gets during the first 48 months? So the maximum number of daily viewers will be when the gradient function is equal to 0. So that's when the rate of change of the viewers is equal to 0. So the turning point of the function. So it will look, so since this is a negative parabola shape, you see this function is a negative parabola, it will look something like this. Sorry, it will look something, not a great drawing, sorry, so let me try this again. It will look something like this, okay? So at this particular point, the gradient is equal to 0, so there's no rate of change of daily viewers. So dv over dt is 0 at this point here. And as you can see here, that will also be the maximum number of daily viewers that this new presenter will be getting. Since on both sides of this point, the number of daily viewers is less than the maximum. So using this information we have, we can simply substitute dv over dt equals to 0 and finding the t value where this occurs, and then substituting that t value back into our equation for v. So it's pretty handy that we already have our dv over dt equation, which is very simply just negative 22t plus 528. And we know dv over dt equals to 0. So therefore, if we substitute dv over dt equals to 0, we'll see that 22t equals to 528. So if we just divide both sides by 22, we should see that t is equal to 24. So now we substitute t equals to 24 back into our equation for the number of daily viewers, the total number of viewers that the presenter will have. The total number of daily viewers that the presenter will have. So v equals to negative 11t squared minus plus 528t. So now v of 24 is equal to negative 11 times 24 squared plus 528 times 24. And that's equal to 6,336 daily viewers. That's the maximum. And so it does not ask us to prove that this is a maximum, so we can simply just leave our answers as follows. And since this is split into part I and part II, this is combined. Usually they give it out as a combined grade for this particular question. So maybe if you can get both parts here, you could get an excellence grade. So getting both I and II will be an excellence. While perhaps only one of the parts will get you a merit. The number of daily viewers for an experienced presenter on a video gaming streaming service can be modeled by the following equation. So that's the equation. And V is the number of daily viewers and T is the time in months. Once the stream reaches 10,000 daily viewers, it becomes monetized. If the daily viewership falls below 10,000, the presenter will lose his income and will no longer make any money. Use calculus methods to determine if the stream, after it becomes monetized, ever stops earning money for the presenter. Alright, so we know that it will become monetized when V is greater than or equal to 10,000 daily viewers. So this question seems a bit daunting at the start, but then the key to solving this question, I would say, is if you differentiate the function, you know that's going to be the rate of change, and you're going to be looking at the points where the function is increasing and decreasing. And you know that when the function is increasing, and if it's always going to be increasing for an entire period, it's going to go above 10,000, and if it's continuing to be increasing during a particular time period, it will not fall below 10,000. And you want to see that during the decreasing period, if the number of daily viewers falls below 10,000. So if that point is below 10,000, then it will lose the income. However, if the minimum point after the decreasing period is above 10,000, then it will not lose the viewership. So we can simply just say that dv over dt, so that's the rate of change, is equal to the derivative of our function for v. And that's going to give us 4.8t squared minus 260t plus 2,900. So first things first, okay, let's solve this equation for when t equals to 0. So let's just solve, not t equals 0, when the rate of change is 0. So let's solve this. Solve for dv over dt equals to 0. So that should give us answers of t equals to 15.7 and t equals to 38.46. Using this information, we can find periods of time when the function is increasing and when the function is decreasing. So we know that this dv over dt is a positive parabola since this a value is greater than 0. So we can just draw out a rough shape of what this will look like. That's not a very good diagram, okay? Let's just do something like that. And it will look something like this. So we're going to have 15.7 here and 38.46 here. We know that this is the equation for the rate of change of the function. So when it lies above the x-axis, this is when it's increasing. And we know that in between these 2 points is below the x-axis, so dv over dt in this case will be less than 0. So between these two values, it will be decreasing. So we just write down that's our analysis. So we're going to say we find that when t is less than 15.7, t is greater than 38.46, then function is increasing. And we know that in between these two values, in between these two values, we will be decreasing. So we know that this function is only valid for between t is 0 and t is 48, so we don't need to worry about any negative values. So from 0, t is between 0 and 15.7, we know that the function is increasing. What we want to know is whether after 15.7 months, whether or not the number of daily viewers will be above or below 10,000 daily viewers. So what we're going to do here is going to plug in our t equals to 15.7 into our original equation. So v of 15.7. So just use our calculator here just to substitute. So we should get in this case, let me double check, sorry. 7. Yeah, it's just some calculator work here. Just make sure you don't make a mistake when you're doing the calculations. Alright, so I am getting 19,678 viewers per day. So obviously this number is much greater than 10,000. So we know that during the initial increasing period from T is between 0 and 15.7 months, we know that between these two times it's increasing, right? So there is no decrease in the number of viewers per day, and it increases to the point of 19,678 viewers per day. So during this period, this particular presenter will have the monetization on their videos. However, we know that after 15.7 and to 38.46 months, there's going to be a decreasing number of viewers per day on the stream. And therefore, we know that since it's decreasing during this period and it's increasing after 38.46 months, the lowest value, the minimum number of viewers, will occur at 38.46 months. So now we want to analyze whether this minimum value is less than 10,000 or whether it's more than 10,000. If it's more than 10,000, the presenter will not lose the income. But if we find that the minimum value here is less than 10,000, we will know that the presenter will lose that viewership income. So what comes next is just V substituting 38.46. And if you do that, you should get a viewership of 10,264 viewers per day. So now we can clearly see that after 38.46, we know that it's increasing. So this cannot drop, therefore this will not drop below 10,264 viewers per day. And therefore this viewership will never drop below 10,000 viewers per day. So we can use that in our analysis. So we can say, since during the decreasing period of T is between 36.46 and 15.7. Since during this decreasing period, the minimum viewers was 10,264 viewers per day, which is higher than 10,000. So the presenter will not lose the income. And for these types of questions, you can also just, rather than using the increasing or decreasing, you can just use the second derivative test to prove whether a specific point is a maximum or a minimum. However, I find that looking at what the behavior of the function is between certain points really helps to visualize this question, which I've done here. So we've been able to see when the graph is increasing and when it's decreasing. So therefore, we've been able to make those conclusions. So that should be okay. So that should be an excellence grade if you can justify and say that the presenter will not lose the income. That should be an excellence. In terms of getting merit grades, if you can get up to this part somewhere around here, that should be a merit. So being able to find the increasing and decreasing points. And to get an achieved, if you can just differentiate and maybe perhaps solve for for dv over dt equals to 0, so somewhere up to here, that could be an achieved. Alright, so now we're moving on to question 2. The graph of the function y equals to f of x is shown on the axis below. Sketch the graph of the gradient functions y equals to f dash of x on the axis below. So both sets of axes have the same horizontal scale. For these questions, this might look a bit daunting. Okay, you've never seen a quartic graph before on a level 2 exam, but if you use the applied knowledge, you should be able to draw the f dash of x. So it's a very similar logic. So f dash of x refers to the gradient function of f of x, right? And the gradient function we can look at is the first key important point is the turning points of f of x. The turning points of f of x is when the gradient is 0, so that will be the x-intercept on f dash of x. So we're going to have this point here, and this point here. That's when f dash of x equals to 0. And we can simply just memorize these points. We have -6 here, 0 here, and positive 6 here. And we can just say that this will be our x-intercept. So those 3 points there, that will be our x-intercepts of the f dash of x axis. Second of all, we can look at the behavior of the graphs in between those turning points. So when x is less than -6, we see that the graph is decreasing. So that's going to be when the f dash of x is below 0. So we're going to have somewhere, the graph's going to pass through that region there. In between -6 and 0, the graph is increasing. So between -6 and 0, the graph will pass through, and it will be above the x-axis, so it'll be somewhere here. And then between 0 and 6, we see that the graph is again decreasing. So therefore, this again will pass through this bottom section here, since f dash of x is less than 0. So now we can just use that information to draw a reasonable curve. Okay, so once again, we don't need to find the exact equation. We don't need to like plug in any points or anything. All we need to know correctly is the correct intercepts and the correct overall shape. So our answer, we can just simply look something like... Sorry, it's a bit more difficult to draw on the device, but if I were doing it in the exam, I might try to make sure that it looks more curved, because this looks like a straight line, which is, it's not supposed to be a straight line, but like I said, it's much harder to draw on this device. So just keep in mind that during the exam, to make it look like more of a generic curve rather than a straight line, as you see here. So it should look something like this. Sorry, once again, it looks pretty messy, but I think you get the general idea. So we have our x-intercepts and we have our correct generic shape, and that should be either, could be an achieved question, could be a merit question. I am not too sure whether that's achieved or merit. Alright, so question B. The function f is given by f of x equals to 5 plus 3x plus cx squared minus 2x power 3. At the point of the graph of the function when x equals to 2, the gradient is -5. Alright, so for this question, we want to find the c value, which we can do by finding the derivative and then substituting the gradient is -5 and the x value is 2. So f dash of x is equal to 3 plus 2cx minus 6x squared. And we know that f dash of x is -5 when x equals to 2. We're just going to substitute that in. Minus 6 times of 2 squared, so -5 equals to 3 plus 6c minus 2 squared is 4, so minus 24. So that should give us a c value of, in this case, it will be equal to 2.67. So that's also 8/3. And that should be our answer, and this should just be a simple achieve level question. So a cliff diver jumps up into the air above a cliff and then falls down to the water below. Acceleration is constant at -9.8 meters per second squared. The diver jumps up with an initial vertical velocity of 2.8 meters per second, and use calculus methods, find the velocity after 1 second. Since they give us the acceleration is constant, that makes our life a lot easier. So we just say that acceleration is equal to -9.8. It's a constant. And by kinematics, we know that we can just use our acceleration to velocity to distance. And then that from going from acceleration to velocity, we need to integrate. So we know that v of t is equal to the integral of a of t with respect to t. So this is equal to the integral of -9.8 dt, which is -9.8 t plus c. We're going to substitute in the condition with the initial vertical velocity is 2.8 meters per second, which is positive. So when t equals to 0, v equals to 2.8, so therefore c equals to 2.8. So v of t is equal to -9.8 t plus 2.1. So we just need to plug in t equals to 1 to find the velocity 1 second after they jump. So v of 1 is equal to -9.8 plus 2.1. And that's going to give us an answer of -7.7 meters per second. And that should be another just straightforward achieve level question. Looking at question number 2. The diver hits the water at a velocity of negative 22.68 meters per second. So negative indicates the diver is moving downwards. Find the maximum height above the water that the diver reached. Alright. So for this question, we started off knowing our velocity functions. We know v of t. V of t is equal to negative 9.8t plus 2.1. Alright, so we know that the maximum height is when ds over dt equals to 0. But due to our knowledge of kinematics, we also know that ds over dt, that is equal to the velocity function. So the maximum height occurs when the velocity is equal to 0. So we can say ds over dt equals 0 for maximum height. So therefore, by logic, this is when v of t equals to 0. So therefore, we can substitute 0 into our equation. So 0 equals to negative 9.8t plus 2.1. And therefore, 2.1 equals to, what am I doing? Okay, 9.8t is equal to 2.1. That should give us a t of 0.2143 seconds. So this will be when the this t value is when the maximum height occurs. And if we just visualize the situation with the cliff, so we're going to have a cliff here. And then our diver is going to initially jump upwards, so it's going to follow some shape like this. And that will be our maximum height. So to make this question simple, we're just going to choose a reference point with respect to our s function. So let's just choose at the starting point when t equals to 0. That's when the diver starts at the cliff. And we're going to say that this is going to be when the displacement is 0. So we're going to take the cliff top as the displacement is 0. And then we're going to use the displacement in respect of these 2 points. So in this case, we can substitute t equals to t equals to 0.2143 seconds into our s of t equation to find the distance traveled upwards in the first 0.2143 seconds. So we know that s of t is equal to the integral of v of t with respect to t, and this will be the integral of negative 9.8t plus 2.1 dt. And this will give us negative 4.9t squared plus 2.1t plus c. And we know that when t equals to 0, we know that with respect to our initial starting point, we're going to say s is equal to 0, thereby c equals to 0. So s of t is equal to negative 4.9t squared plus 2.1t. And substituting the time value of 0.2143, we're going to get negative 4.9 of 0.2143 squared plus 2.1 times of 0.2143. So we have 0.2143 squared times negative 4.9 plus 2.1. Alright, so that should give us an answer of 0.225 meters. So keep in mind, this is not our final answer. Okay, so some people might just leave our answer as this, but that's not the correct answer. This distance refers to this distance here, so the amount traveled here. However, the question is trying to find the maximum height above the water, so that's with respect to this point here. So the 0.225 meters is the displacement with respect to the top of the cliff top, not the water. So 0.225 is not the final answer. We need to add 0.225 to the height of the cliff to get our final answer. And this is done by, since they told us that the diver hit the velocity, the diver hit the water at the velocity of negative 22.68 meters per second, and we can use that to find the time value when the velocity is negative 22.68 meters per second, and substituting this into our displacement formula. So we can substitute negative 22.68 into our velocity formula, which is 9.8t plus 2.1. And that should give us a time value of 2.5286 seconds. And all we need to do is substitute this point into our S of t equation. So S of 2.5286 is equal to negative 4.92.9286 squared plus 2.1 times of 2.5286. Plus 2.1. Sorry, what am I doing? Okay, so we have this. 22.68. So multiplying by answer squared times plus 2.1 times 2. Alright, so I am getting an answer of negative 21. Oh, not 21. Displacement is negative 26.02 meters. And remember that this displacement is with respect to the top of the cliff, so that's here. So this will be negative 26.02 meters with respect to the cliff top. So in this case, our total distance will be 26.02 plus 0.225. So total is 26.02 plus 0.225. And that should give us an answer of 26.24 meters. And that should be our final answer for this question. And this should be an excellence level question, without a doubt. To get a merit grade, if you can find the initial distance from the top of the cliff, that could be a merit. And an achieved could be just simply just finding maximum height. Sorry, the maximum height above the cliff top could be an achieved. Alright, so question 3. A curve passes through the point 1, 2.5 and has the derivative function of 6x squared plus 5x minus 1. Find the coordinates of the point on the curve where y equals to f of x when x equals to 2. So this will be an integration question. Okay, so we need to integrate to find our function, and then we're going to substitute the point 1, 2.5 to find our c value. And then after we find our c value, we're going to plug in x equals to 2 and find the y value, which will be the coordinates. So in this case, f dash of x equals to 6x squared plus 5x minus 1. So integral of 6x squared plus 5x minus 1, that is going to be equal to f of x. And that's going to be, so we're going to increase the power by 1 and then divide by the new power. So in this case, we're going to have 6x to the power 3 divided by 3 plus 5x squared divided by 2 minus x plus c. So in this case, if we simplify a little bit, we're going to have 2x to the power 3 plus 5 over 2x squared minus x plus c. And we know that the curve passes through the point 1, 2.5. So 2.5 is equal to 2 plus 5 over 2 minus 1 plus c. And we can find our c value by just rearranging for c. So you should see that c equals to negative 1. So therefore f of x rather. F of x is equal to 2x to the power 3 plus 5 over 2x squared minus x minus 1. And we need to substitute the x equals to 2 into our equation to find the point y equals to f of x. So f of 2 is equal to 2 times of 8 plus 5 over 2 times of 4 minus 2 minus 1. And that's equal to 16 plus 5 times 4 is 20, so divide by 2 is 10, minus 2 minus 1. So 16 plus 10 is 26, minus 2 is 24, minus 1 is 23. So the point will be 2, 23. And that should be just an achieved question there. An electric scooter is traveling down the straight footpath. Its velocity t seconds after passing a sign is given by v of t equals to 0.3 t squared plus 1. How fast is the scooter from the sign when t equals to 3? So once again, this is our kinematics question. So we're going to integrate to find our equation for the displacement, so s of t. So the s of t is equal to the integral of v of t with respect to t. And this will be 0.3 t3 divided by 3 plus t plus c. And this will give us 0.1 t to the power 3 plus t plus c. So it's velocity t seconds after passing a sign. So it's from the sign. So therefore, when t equals to 0, s equals to 0. So therefore, c equals to 0. And now all we need to do is substitute t equals to 3 to find the displacement. So s of 3 is equal to 0.1 times of 3 cubed plus plus t, which is 3. So that's equals to 2.7 plus 3, which is equal to 5.7 meters, which is our final answer there. And that should be just another achieved level question there. The diagram below shows the graph of the gradient function f dash of x. So we want to go back and sketch f of x. So for this question, it's just very similar to question 2a, but instead we're going to go backwards. So looking at this f dash of x, we know that the turning points of this cubic will be at x equals to 2 and x equals to 10. And that's going to be our positions of our turning points. We're just going to mark that on our graph here. So x equals to 2, x equals to 10. When x is less than 2, the graph is increasing. And in this case, what am I doing? Sorry. We have x equals to 2 and x equals to 10, which is our turning points. This is f dash of x. So below the x-axis, this is going to be our f dash of x is less than 0. F dash of x is greater than 0. And this will be f dash of x greater than 0 and f dash of x less than 0. So when x is less than 2, it's decreasing. That's what we know. So we're going to have our graph coming down in this portion. And then when x is between 10 and 2, our graph is above the x-axis, so it's going to be increasing. So it's going to be, after this point, it's going to be increasing. And then when x is greater than 10, it's going to be decreasing again, okay? So that will be the overall shape of the graph. So this doesn't really matter how you draw it because you don't really need the exact formula of the graph. So just a rough sketch will be enough. So it could look something like this. Alright, so that matches all of the requirements. We have our turning points at x equals to 10 and x equals to 2. It's decreasing when x is less than 2. It's increasing when x is between 10 and 2. And it's decreasing after x is greater than 10. And that should just be another just straightforward achieved question there. So two possible configurations of a house shape drawn below a parabola are shown below. A house shape is drawn and C is the point 0, 9. A and B are on the points y equals to 9 minus x squared. E and F are on the x-axis. And then find the height of the wall AF or BE. When the house shape is the maximum, the area. So in this case, it looks pretty daunting, but in this case, we see that there's only two generic shapes inside this house. We have a triangle and we have this rectangle. So the total area is just simply the triangle area plus the rectangle area. The rectangle area we can see is just simply x times of y. So we're going to say that area is equal to x times of y. But keep in mind that there's also x times of y on the left-hand side as well. So this will just be plus xy. And then that will be added to the area of the triangle. So notice that the area of the triangle, so this length here is also just going to be the x value, and in this case, this y value will be 9. So we have the y value here is 9 minus this length L here. So we can just write that down as area is equal to 2xy plus 2 times of 1/2 times of base height, which is x times of 9 minus L. In this case, L is just simply the y value for the x values here. So if we substitute, what am I saying? Okay. If we substitute x into our equation, we're going to see y equals to 9 minus x squared. So therefore, we know that L is equal to 9 minus x squared. Right, so we also know that y equals to 9 minus x squared. So therefore, area is equal to 2x times of y, which in this case is 9 minus x squared, plus 2 times of 1/2, which is just 1, times of x times of 9 minus x squared. So area equals to, just simplify this one, so we have 18x minus 2x to the power 3, plus x times of 9 minus 9 is 0, negative of negative x squared is positive x squared. So area is equal to 18x minus 2x to the power 3 plus x to the power 3. And area equals to 18x minus x to the power 3. So therefore, if we find the derivative and make equal to 0, we'll find the maximum. So dA over dx is 18 minus 3x squared. So therefore, 3x squared equals to 18. X squared equals to 18 over 3. So x squared equals to 6. And thereby x equals to plus or minus root 6. And then it wants us to find the height of the wall, so that's AF or BE. So the height is simply just plugging in x equals to square root of 6 back into our equation for the parabola. So height equals to 9 minus x squared, which is equal to 9 minus of square root of 6 squared, which is 9 minus 6, which is 3 units. And that should be our final answer, and this should possibly be an excellence level grade with a merit. If you can get a merit which is a minor mistake, possibly if you forget to account for one of the particular areas, that could be a merit. If you to get an achieved, if you can simply just write down the equation for the area, that certainly should be enough evidence for an achieved. So somewhere here, that's definitely sufficient for an achieved grade. For the generalized problem, when the house shape is bounded by a parabola, C is at 0D, A and B are on the parabola y equals to d minus kx squared, E and F are on the x-axis. Show that the maximum area enclosed by the house shape occurs when the area of the rectangular section ABEF and the area of the triangular section ABC are equal. Alright, so again, this might look very, very daunting, okay, but once again, it's just two things we have to work with. Area equals to the triangle area plus the rectangle area. So rectangle area plus triangle area is total area. So in this case, it's very similar. So we have our x value here and our y value here, and then we have x and this length here. So the area is equal to 2xy, which is the area of the rectangle, the entire rectangle, plus 2 times of 1/2 base times height, as there's two triangles, one triangle here and one triangle there. And then multiply by base, which is x, times of height, which is d minus L. In this case, we have d minus kx squared as the parabola, and therefore we know that this y equals to d minus kx squared. So therefore we know that L is equal to, this point is d, so therefore d minus kx squared, which is kx squared. So therefore A equals to 2x times of y, which in this case would be d minus kx squared. So that would be d minus kx squared. And then we're going to have plus of x minus d minus L, which was kx squared. So if we simplify this a little bit, we'll get 2xd minus k. We're going to have 2xd minus 2kx to the power 3 plus kx to the power 3 here. So we have a equals to 2xd minus kx to the power 3. And so we have this generalized form. We're going to differentiate. So dA over dx equals to 2d minus 3kx squared. and thereby 3kx squared, since dA over dx equals to 0 for maximum area, so that's going to be equal to 2d. So x squared equals to 2d over 3k, and x equals to plus or minus square root of 2d over 3k. And now we're going to separate this into the area of the triangle and then the area of the rectangle. So the area of the rectangle is 2xy, so that will just be 2 times of square root of 2d over 3k times of y, which was d minus kx squared. So d minus kx squared. So d minus kx squared, that's y, so therefore y equals to d minus k times of 3d over 2d, sorry. K times of 2d over 3k. So k and k cancel each other out. So y equals to d minus 2d over 3, which is just d over 3. So this will just be times of d over 3. That will be the area of the rectangle. Rectangle is equal to 2 times of d over 3 square root of 2d over 3k. So similarly, we can look at the two triangles. So the triangle area was triangles was 1/2 times of 2 times of what was it again? It was d minus L times of x. So 1/2 and 2 will cancel each other out for 1, and then we'll have d minus L, which in this case was kx squared. In case we have kx squared times of x. So kx squared, our x squared was equal to 2d over 3k, and therefore we know that x is equal to square root of 2d over 3k, and therefore kx to the power 3 is equal to kx squared times of x, which is equal to k times of 2d over 3k times of 2d over 3k. And if we simplify this a little bit, we're going to see that this is equal to 2d over 3 times of square root of 2d over 3k. And that is the same as the rectangle area. So you see these two expressions are the same. So if we just get rid of this, we have this and this. And those two are the exact same expressions. So therefore we can say that therefore the area of the rectangle is equal to the area of the triangle, which is as required. And that will be an excellence grade for sure. A merit grade should come if you can find the x value, the generic x value for the maximum area, which is this point here. And then achieved should be if you can find an expression, a generic expression for the area. So generic expression for the area, that should be an achieved. Alright, and that's it for this calculus paper. Once again, it looked like a pretty challenging paper, but with the knowledge of level 2, I do think it was a doable paper. And I do hope you enjoyed the video, and I hope to see you all in the future.